Hello, everybody. I really appreciate everyone who was able to attend today, both in person and online. I'm really excited to share about a really awesome tool I've been playing around with recently called VisionAgent and how you can use it to hopefully simplify your computer vision tasks in Python. So a brief introduction about myself. My name is Brendan Carnell. I just recently accepted underground gas line staking position at DTE Energy, which has been incredible so far, and I'm really grateful for that opportunity. But in my spare time, I really enjoy programming and learning to program, primarily Python. And my favorite sort of projects to work on are automation tools that help me run my eBay store more efficiently. So what is VisionAgent? VisionAgent is a computer vision API that was created by a company named Landing AI. And their mission statement is to get developers from idea to application as quickly as possible. And they do that by making it so you don't need to be an expert in training machine learning models or a neural net to tackle some pretty complex computer vision tasks. All you have to do is be able to upload an image, describe what you want, and then they're going to return you results. And the results are going to be returned to you in the form of either bounding boxes for object detection or structured fields for document extraction. And all of the processing and model running is handled in their cloud, which makes integrating it into your application incredibly simple and very lightweight. So for my own, um, sorry, this is bothering me. All right. You can also hit the OK there too. Yeah, there you go. No, I can't get to the. There you go. All right, sorry. From my own experience, this is kind of, the traditional workflow when you were trying to work on some sort of computer vision project. For context, I was trying to create a automated listing tool that was looking at the front and back image of a sports card. And then from there, I wanted to be able to bounding box the fields like the player's name and the brand, and then extract that text and format it into a title. And some of the hurdles that I faced were first gathering a large data set and then hand labeling it. Then I had to decide if I wanted to try and train my own model or run a bunch of tests with pre-trained models and see if anything worked best. I had to set up compute infrastructure. I was paying $10 a month on Google Colab to try and run my models and train it using their GPUs and TPUs. You have to handle all of the post-processing logic yourself, like filtering results, and then you'd also need to find a way to host your model and maintain versioning. And now that same kind of project with VisionAgent, you can just upload an image or have a way for a user to upload an image, write a natural language prompt or already have one defined. VisionAgent will again handle everything in their cloud and then return you either the bounding boxes or the structured data for the document extraction. So how it works, when you send your prompt and your image to VisionAgent's API, it's going to be interpreted by a large language model. At the time of this presentation, they use both ChatGPT and Claude Sonnet. And it's going to take your prompt and structure it into a more like a set of steps for what it thinks you're trying to achieve. And then it's going to pass those instructions off to a reasoning agent that is going to look at what it thinks you want to achieve, come up with a plan, decide on what libraries, tools, things like that to use. And then the reasoning agent will then pass it off to VisionAgent that will actually run a bunch of tests with a bunch of different generated code. It'll pass all of those results back off to the reasoning agent, which is then going to look them over, determine which one are the best, and return just those ones to you or your user. So we have 3 demos we're going to go over today. The first one is just going to be a single cat detection. So we're going to upload an image to VisionAgent and ask it to find the cat. We're going to try to keep as much of a minimal setup as possible, just passing it the image and the prompt. And our response should hopefully include bounding boxes, labels, and the model's confidence score. So for imports in our libraries, we're going to import requests. That'll be how we communicate with VisionAgent's API. OS, this will be how we interact with our environment variables within our program. From the pill library, we're going to import the image module and the image draw module. And then from the .env library, we're going to import the load.env function. Then we're going to call that function. And why we're doing that is because that's going to be how we load all of our sensitive information, in this case, our API key, into our virtual environment. And that way we don't get in the habit of hard scripting or hard coding sensitive information into our scripts and then accidentally uploading it to GitHub or presenting it to an audience or something like that. So once we run this function, then we can here, when we create our API key variable, we can use this os.getEnv method to go inside our .env file and extract our VisionAgent API key. Then we have some error handling just to check to make sure that our API key exists. Here we define our VisionAgent URL endpoint. So for this task, we're going to be sending it to this back part is what's important, this agentic object detection. So based on whatever it is you're trying to achieve, this would be the part you change in the URL. Our image path will be this test Sophie 2. Then we just have here again some more error handling to make sure that our image path exists. Now we're going to open our file. So we're going to say with open and then pass it our image path. And then this RB means for it to be read in binary, as that's required by VisionAgent's API. And then we're going to save it as image file. Then we're going to create this files dictionary. The key is going to be the image, and the value will be our image file we just created in that binary format. This data variable, this is where we defined our prompt that we're sending to the model. So for this one, we just have find the cat in this image, just make a bounding box around its head. And the model we want to use is agentic. And then for headers, this is just going to be our basic authorization, and we just passed it our API key. So now we're going to send our post request to VisionAgent's API. We're going to pass it our VisionAgent URL, our files, which is our image path, our data, which is again the prompt and the model we want to use, and the headers is our API key. And we're going to store that. It's going to return the data in raw JSON format, and we're going to store that in this response variable. So this line, we're just checking to make sure that the status code was 200 and that our API call was successful. And if it was, we'll print this message to our terminal to let us know that everything is working okay. Now here we're going to create this image variable and a drawing instance. So we're going to, from the image module, we're going to use the .open function and pass it our image path. And then this draw variable, we're going to, from the image draw module, use the .draw function and pass it our image. And that way, once we pass this draw variable, the coordinates of the bounding box, it'll be able to just draw them right onto our image. So now in this line, we're going to take our raw JSON response from the API and turn it into a Python dictionary with this .json function. And then from there, we're going to use the .get method to find the data key in that dictionary. And what that value should be is a list of lists. So here we just have an empty list of lists in case something goes wrong and nothing is returned. Otherwise, we're going to index that first inner list within that list of lists. So I do have a slide to go over that a little bit more. So this is what our results variable looks like. It's going to be that first inner list. And inside of that list is a dictionary that contains a single detection. And it should have the bounding box coordinates, the label that the model gave the image, and the confidence score. And the reason it's set up to be a list of lists is that VisionAgent's API is set up to handle multiple prompts within one call. So if we had a prompt that said, find all the cats in this image, and then we created another prompt and it was find all the dogs, there would be two lists. So we would look for that second index to get the detection of the dog if there was a second prompt. Does anyone have any questions on that? Does that make sense? Okay, so now we'll make sure that there is some data in our results variable, and if not, we'll just simply exit our program. And now we're going to go through and extract the box value and the score value from that dictionary. We're going to do that by, again, going inside that inner list. looking for that bounding box key inside that dictionary, and then storing those coordinates in this variable. And we do the exact same thing for score, going inside that first inner list, finding that score key inside that dictionary, and storing its value here. So now we're going to call on that drawing instance that we created earlier using the dot rectangle function, passing it our box variable, which should be our coordinates, our outline. This is where you choose your color. I chose red. And then width, we chose 3 pixels. And then for the text, you use the dot text function. And then this first part here, this box 0 plus 5, comma, box 1 plus 5, this is the coordinate of where you want the text to be. And this box 0 and box 1 is the XY coordinate of the top left corner. And then the plus 5 moves it 5 pixels over. That way the text doesn't overlap with the bounding box. And then we use an F string to write what we want the text to be. And we have cat and then our score formatted 2 decimal places. And then again, we just choose the color and it's red. Then we just save the image. So let's run this and see if VisionAgent's able to find the cat in this image. It does take a while to run the first time you run each demo. So these were some of the images that I tested it on originally. These were kind of layups. In my opinion, it was able to, the bounding box isn't here, but it found this is Scorp, no problem. We have our result. All right, so as you can see, this was the hardest image I tried to give it. This is Sophie, and it had no problem finding her, even though her face was hardly visible and her fur both blends in with the floor and the jacket. So I was pretty impressed when I seen that. But now I want to see if you're able to scale VisionAgent to multiple prompts or multiple detections within one image with as minimal changes as possible. So that'll be our next demo. It's going to be this multi-cat detection. What we're going to do is change our prompt to find all the cats in this image. It'll pretty much have the same API flow as demo 1, and it gives me a great excuse to show off both my cats to all of you today. Whoops. All right, so I won't go over everything because most of it's the same. We have all the same imports and libraries. We use our load.env function. We have our same URL, our image path, and then you'll see here what's different. We have this resize path, and I'll explain why that is in a second. So here, when we create our image variable, we're going to use from the image module, the .open function, pass it our image path, and then we're going to use this .resize function and resize it to 1024 pixels by 1024 pixels. And the reason we're going to do that is because when I was just sending the images to VisionAgent's API as they were off my phone, it was finding both cats at once, but it was making multiple bounding boxes on each one, like 3 to 5 per. And instead of doing some complicated intersection over union math, I read that if you reformat multiple detections from one prompt to this size, that it handles it much better, and it did solve the issue. So then we save our resize path, and we're going to open it the same way as before in the read binary format and save it as our image file. Our files dictionary is the exact same. Here in our data, you'll see that our prompt has changed. It's find all the cats in this image. Same basic authorization for our headers, same post request. We again turn the JSON response into a Python dictionary and get that data key. And now inside of that first inner list, since we're asking it for multiple detections, there will be 2 dictionaries instead of 1. So again, we'll check to make sure that there is some sort of data in our results. And then just like before, we're going to get our boxes and scores, but this time we're just going to loop through, since there's multiple, each cat detection dictionary in our results list and extract the bounding box and store it here in this variable. And then we're going to do the exact same thing for score, loop through each cat detection in our results list, go in those inner dictionaries, get the score key, and store those values here. So now we're going to create our drawing instance exactly how we did before with the .draw function and passing it the image. And then we're going to loop through each box in our boxes list and draw them onto our image, doing it exactly as before with the .rectangle function, passing it the coordinates, the outline, and the width. And then the same thing for the text, putting it at that top left corner, moving it 5 pixels, and then our F string. So let's see if it's able to scale up to multiple detections in one image.
While it's doing that, Tina had a good time for a question.
Yeah.
Tina online was asking about what about pre-processing and is there any like API limits for using VisionAgent?
Yeah. So when you are just sending one prompt, it kind of has to be somewhat simple. There is, when you go, when you set the URL, there is, instead of agentic object detection, it's like multiple prompt something. And then you can ask it to do multiple things and it'll work in multiple steps instead of all at once. But there definitely is a limitation if you're using just agentic object detection, if that answers the question. All right. And again, it was able to find both Sophie and Scorp with no problem, label them pretty well. And then there's our text with our confidence score from the model.
DN online was also asking if there should be labeling on the bounding boxes.
Yes. Yeah, it's what we just zoomed in
Cool.
on is the label. And in this one, you'll see the labels a lot more clearly. Okay, so for the next demo, it's going to be around line clearance, tree trimming, planning. So not as fun as the cat detections, but more of a real world process. For context, before I just recently accepted a role at DTE Energy, I was in the arborist industry for the last 5 years, trimming and removing trees every day. So I have a lot of experience with this. And what line clearance planning is identifying hazardous trees near overhead power lines. And some of our required clearance standards from our utility companies here in Michigan is 4 feet clearance for conifers or evergreen trees, 10 foot of clearance for deciduous trees, and any overhead branches that cross over all phases of the primary are all deemed hazardous. And some of the challenges with line clearance planning is visually estimating distance is incredibly subjective and very error prone. Planning across large areas can be incredibly time intensive, as well as a lot of these areas in more rural parts of the state. It can be really hard to get to some of these spans. You may have to cross creeks. And that ends up with someone just looking down the span with binoculars and trying to line that up with their interface on their iPad and mark what trees need to be trimmed. So our objective for this demo will be to automatically detect tree branches and power lines within an image, and then we're going to flag areas that violate our clearance standards. We're going to measure the distance between branches and power lines using pixels, and we're going to provide visual output to assist with line clearance planning. And then before we go over to the code, so this code that I'm about to show you was also generated by VisionAgent on their playground. So I'm going to show you how to do that first. I tried using the API and trying some different endpoints and different models to get it to work. This is kind of a bad example, but this is some of the stuff I was running into. It was kind of just labeling everything as the prompt. Those bounding boxes really don't make any sense. As well as when I was getting it to work, it would make like hundreds of bounding boxes over the power line instead of trying to just make it one. So I went to, got it. So you can go to this landing AI/home and go to this agentic object detection. And what you do is you upload an image and then you write a prompt. So I wrote something like find all the tree branches and power lines in this image. label any branches within 10 feet as needing trimmed. Otherwise, mark them as okay. And then I uploaded the first image that I'm going to show you when we run the demo. And then this can take 10, 15, 20 minutes to run and complete. So we're obviously not going to do that today because of time restraints. But then what shows up here is not just your image with hopefully the labels how you wanted it, but also attached will be the Python code that it ran to generate that result that you can then take and integrate into your application or just use as is. So since then, I have tried to understand to the best of my ability what this code is doing. So we'll go through it together. And then, so from VisionAgent.tools, it imported this asterisk, which I have learned is a wildcard import, meaning it imported every tool from this module, and it's now just accessible later by name. And then from Pillow Hive, it imported this register Hive opener function. And what that's doing is making sure that your application can handle images uploaded from either iPhones or newer devices that run on the Hive and Hike format. Then we have our main function here, this define detect tree branch proximity. It's going to take in our image path, our threshold pixels, which will be float and 50 pixels. And then we just define our output path. And then inside of the import, it has some more, or inside of the function, excuse me, it has some more imports. So from VisionAgent.tools, it imports these utility functions. It imports load image, which is going to be used to load the image in the format that the model expects. Save image is just going to be how we save our image. This overlay segmentation masks, that's going to be used to actually draw our labels onto our image. And then this minimum distance tool will be used to calculate the distance between each branch and every power line within the image.
Question.
Yeah.
Not on the demo so much, it's just that you're importing inside of a function. What's the advantage of that? Because I usually just do it up top.
So do I. This is the code generated by VisionAgent's Playground. So I had that same question, and I actually asked that question in the VisionAgent Discord, and one of their machine learning engineers told me it was probably thinking maybe that'll make this function portable and self-contained. That was his answer to
You
me.
can like avoid circular dependencies. I've had to do it just specifically for that.
Okay.
Sometimes it can be an optimization thing where certain functions don't need to be called every time a program executes. You can only do, it'll only import libraries if that function's called, so you don't need to do all those imports up top.
Yeah.
Thanks.
And then here, so from VisionAgent.tools, we're going to import this count GD SAM2 instance segmentation. And this is the pre-trained computer vision module that VisionAgent chose for this task. So now we're going to load our image. So we'll define our image variable and use that load image tool that VisionAgent imported. Pass it our image path. And the way it's loading this image is in a NumPy array, and it's doing it 10,024 pixels high, 790 pixels wide, and 3 color channels. I believe the color channels are RGB. And then we're going to store the height and the width in variables. And we're going to do that by stripping the first two from our image shape. So now we're going to create our detections variable. So we're going to call on our pre-trained model, this count GD SAM2 instance segmentation, tell it we want it to find all of the tree branches, all of the power lines, and we want it to find them from our image. So now kind of how we were going through the and taking the boxes and the scores out in the previous demo, we're going to do that same thing here, except we're going to find the branch detections and the line detection. And we're going to do that by looping through every detection dictionary in our detections variable. And if the word branch is present in the label, we're going to store it here in our branches list, and then do the exact same thing for power lines, loop through every detection dictionary in our detections list. If the label includes the word line, we'll store it here. So this is going to be where we do all of the measuring and computing the minimum distance between each branch and its nearest power line. So we create an empty list in this variable results, and then we use enumerate to loop through every branch in our branches list, and that gives it a branch ID that we can later reference so we know which branch we're talking about. Now we're going to create this empty list branch distances, and from there we're going to loop through every single power line in our lines list, create this distance variable using the minimum distance tool that VisionAgent imported, and we're checking the distance between that specific branch and each power line in the image, and we're checking it with the height and width variable. The height and width variables that we made earlier. And then we're going to append that distance to our branch distance list. So I made an example here. So each branch will have a list that looks like this, and this is the distance between each power line in the image. So for this example, the closest power line to that branch is 39.7 pixels away. And then we're going to create this needs trimming variable, and that is going to be a, excuse me, a Boolean value. And we're going to check that by seeing if minimum distance is less than our threshold pixels, which is 50. So in our example here, this would be set to true. And then from there, we're going to append a dictionary for each branch to our results list. And that dictionary is going to have the branch ID, the minimum distance, and then whether or not that branch needs trimming. So what we're going to do here in this for loop is relabel every tree branch. So for each trim result, which is referencing this dictionary that we just added to the results list, we're going to assign our branch ID, and then we're going to check if that needs trimming value is true. And if it is, we are going to change the label to branch needs trimming. And our else case, which would be if needs trimming is false, we will just change our branch label to branch OK. And then for simplicity, we're just going to go through every single power line detection in our lines list and label it as a power line, as it's not incredibly important that we label it as distribution, primary, secondary, service, and so on. Now we're going to combine our updated detection list in this variable annotated detections. And we're going to do that by simply just combining branches and lines. And then we're going to create our final image. So we're going to, this out image, we're going to use that overlay segmentations mask tool and tell it to combine both the image and our annotated detections variable. Then we save our image and return our output path. Then we have this if dunder name equals dunder main. What this is doing is making sure that this only runs either if you run it directly from your terminal or your code editor, and it's not going to run on import. So the first example that I would like to run is the image that I uploaded to VisionAgent's playground to get this code. Once you run it once within the same demo, every time you run it after that without exiting out, it does run a lot faster, just so everybody knows if they plan to use it.
Is most of that runtime, is that the server processing it, or is it okay?
Yeah, I believe so. But I don't know if that would explain why. Like we'll see when we run the next image for the same code, it's going to run like 100 times faster than that and get us our result.
Or downloads the model locally or something.
So this compared to earlier is obviously much better. So in my opinion, this really blew me away. It labeled all the power lines as it should. This up here, this is my good friend who I used to work with. His name is Dawson. He had already trimmed everything that needed to be trimmed and was saving this piece hanging over the power lines for last. So it accurately labeled this branch as needing trimming. You will see it did label his rope that he is tied into the tree with as a power line, which obviously not be good, as well as this line that we're using to rope the piece off is also labeled as a power line, which makes some branches up here be labeled as need trimming. But ultimately that would be okay because whether or not a tree needs trimmed is a classification problem. It either needs to be trimmed or it doesn't, whether there's 100 branches or one. So this would be okay in my opinion. But I was really curious if this code would transfer to other images or if it would just work off the one that I uploaded it with and it generated it from. So I do have another result or another test I would like to run. See, that was much faster. All right, there we go. So here's another one that the VisionAgent didn't see, and its code it generated still worked perfectly fine. It labeled all the primary and high distribution lines in this image as power lines. It labeled this entire pine tree as one branch, which would actually be in the real world, if utility companies were to use this, this is the way you would want to do it because, again, it's a classification problem. And I also know that this tree is plenty clear because I am the one who trimmed it and then took this picture back in the day. So yeah, I was really impressed. I think VisionAgent is a really awesome tool. It makes really complex tasks like this accessible to pretty much anybody who can write a little bit of code and set up an editor. It has a really generous free tier. They offer 1,000 API calls a month, every month for free. All they ask is that if you are creating something for profit to please use one of their enterprise options, which are also incredibly affordable, in my opinion. And I do want to show in the playground, I don't have a demo for the agentic document extraction, but I know someone in here does a lot of work with documents. So I wanted to show in the playground kind of what this can do. So this is like the busiest form that they offer. It's this accident report. You can get it in Markdown, which is all these structured fields, or you can just get the JSON data and then maybe set up a super easy query from there. You can also chat with the documents. So you can ask it for results from things like this. It's also, to my understanding, a quite a bit more powerful than just normal OCR because it can look at this diagram and understand what's going on and make decisions based off that, as well as checkboxes are a couple of the big things. So yeah, it's a really fun tool to even just go on their playground and mess around with some of the APIs. They have a really cool API coming soon where you can upload a video as long as it's less than 30 minutes long and ask to timestamp a specific something that goes on, and it will timestamp it and then also label it at that timestamp for you to easily go through later on. So yeah, it's a really cool tool. I really hope if anybody's been sitting on a computer vision idea, they give VisionAgent a try. And then lastly, I'd just like to again say thank you to everybody who came today. I really appreciate it. It means a lot. And also everybody who was online.
Okay.
I saw Xander Online was asking about, I think, your evergreen tree, if it should have labeled the other trees in the image as well.
So yeah, I mean, based off what my original prompt was, I would think yes. But I was wondering if maybe somewhere along the line when it was doing its reasoning or running its test, if it just measured the distance from that tree and determined, hey, it's so far from these power lines, why label it? I am really hoping one of my friends has a really powerful drone, and in practice, I imagine that these spans of power lines would be surveyed by a drone from overhead. I feel like the clearance would be a lot easier to tell coming down. And also, if you're going to have somebody go take a picture of every tree, you might as well just have a human label them. So, yeah, I wonder once I can get with him and we can get some really cool footage like that, I am going to run some more tests and see if it is just labeling the ones close or if it'll label everything. I'm not really sure. That is a good question that I wondered as well.
I was wondering, so when you were doing your distance calculations, you were doing it off of pixels, right?
Yeah.
Have you tried to see if any of the language models can detect like feet? Could like if it knows if you can see like a power line and a tree in it, can it determine how like you know, can you use a reference for how big those things are to try to determine distance? I don't know if you've looked at that at all.
I did because when I was trying to originally make the code before I used the VisionAgent playground, I couldn't make anything, and then I was trying to use, ChatGPT 4.0 to see if it could make anything. And when it was like running its tests, it was also just turning the image into a NumPy array and then measuring by pixels as well. But it wasn't able to get as good of results for the VisionAgent code generator for computer vision tasks. They really have like that code generator pretty good in my opinion over the normal large language models.
Not a super technical question, but just wondering, like, so this algorithm that they're using kind of, behind the scenes that their server's running, do we think like this kind of technology's been around for a while, but now like the LLM allows us to, we're interpreting the language layer of it and then using this kind of algorithm that, feel like image recognition, like that's been around for a while, but now it's just kind of bringing those two things together. Is that kind of what's happening?
Yeah, I would think that just because the way that they have it set up to, they're using a large language model to break it down, and then they're passing it to like an army of AI agents behind the scene that are each have their own specific task. And I feel like the LLM makes it really easy for all of those agents to interact as well, in my opinion. I don't really know. That's
Yeah.
just what I think, but
It's cloud-based, but it's kind of a different slant on things.
Yep. For sure. It just seems like now there's all this like modular technology that's existed, and now throw this LLM layer on it, and it just opens up the door for all this stuff, right? It's just like pretty cool.
yeah, it is really cool. It's awesome.
Like, could VisionAgent be used for like any sort of like real-time bounding boxes on videos, or is it mainly for like async request responses, like in your examples?
I believe it's request responses.
Okay, so they don't have any like WebSockets or anything comparable for real-time video.
They might, but the only video thing they have coming out that I know is the where you can upload an image and have it timestamp specific things.
Oh, makes
But
sense.
they might.
Yeah, guess
but I
it'd be a
don't think
lot
so.
harder to do like real time since like get a lot more constraints there.
Yeah. It's a great question.
For the talk, a few questions. What are the rights? Like if you upload an image, like does it actually feed into their existing model? Is that like public? Like,
That is a great question that I do not know the answer to.
so everyone, second, is there a room for an iteration? So like cats and dogs and like distances are more concrete. But what if it's something more nuanced? Like find the criminal, right? Like what is a criminal? You have to define it, right? And like kind of the way things are used these days is not really clear.
No, I think based off all the examples that I've made, as well as the ones that they have on their playground, it's more of like a big aisle in a grocery store and it's like find all the Kellogg boxes, or it's like an assembly line at a plant and it's like find the pieces with defects or things like that that are kind of already predefined.
What happens if that's not the case? Like, does it not give you anything, or it will still try to answer something?
I've never tried. I imagine it would still generate some sort of code. But yeah, everything I've tried has been pretty concrete, so I haven't ran into it. That is like a really good test and idea.
Sorry, last question. Can you specify like upload your own model?
You can actually, yeah.
Oh, okay.
Yeah, that's a little bit out of my realm, but I have seen that. It's instead of going to their APIs, you go to the landing lens tab on their website, and you can like upload or pre-train your own custom model. Something.
Okay, thank you.
Yeah, no problem.
Good ethical questions too.
Right.
I saw online, DN asked, is the demo code and images available as a repo to experiment from?
It will be tonight. And when it is, I will post it in our Discord.
Any other questions online or in person?
I think you go to this part right here, the landing lines.
All right. Thanks again, Brandon.
Thank you.